The next ones are factoring a difference of squares in one variable. The difference of squares is pretty easy to factor because we know it factors into conjugates. And so if you recognize that it's the difference of squares, difference means I'm subtracting and both of these are perfect squares, yes it is, then it's not too bad to factor. It does factor into your two binomials, so you have your two sets of parentheses, but basically you're doing the square root of each term. One will have a plus and one will have a minus. So 64 is 8 times 8. 81v squared is 9v times 9v, and one term will have a plus and one term will have a minus, so that when you FOIL it out, the middle term cancels out. So just for fun, if I'm checking this one, 8 times 8 is 64. My outside is negative 72v. My inside gives me positive 72v. And then the last 9v times negative 9v is negative 81v squared. You'll see that your middle terms become opposites, and that's how we end up with that difference of squares, by multiplying what they call conjugate. It's the same values with opposite signs in the middle. So again, if I recognize, oh yep, I have the difference of perfect squares, it tells me to factor. I'm going to start with my two sets of parentheses. 25z squared would be 5z times 5z. 4 is 2 times 2. I know that I have to have conjugates, one plus and one minus, so when I FOIL it out, the middle term cancels out. So number 15, if I'm going to factor that, again, if I recognize it's a difference of squares, I can just put my two sets of parentheses. 49, 7 times 7. 64, z squared would be 8z times 8z. And then again, I have to have one with the plus and one with the minus. So I get 7 plus 8z and 7 minus 8z. So factoring the difference of squares, fairly easy as long as you recognize that's what you have when you're factoring.